So you need your Unit 3 handout in front of you. That unit deals with, I call it trigonometry A. Primarily it deals with what's called coordinate trigonometry. And we're going to be looking at textbook section 4.1 today. I break it apart into two lessons, and the first one is going to be introduction to some new ideas that you haven't seen before, but also a review of some things that you have seen before. To begin with, we finally define in high school mathematics what a radian is. You're always told when you reset your calculator to make sure that you put it into degree mode, and that's simply not necessarily going to be the case from now on. You may want it in degree mode and you may want it in radian mode. But let's talk about what a radian is first. 1 radian is an angle. The word is subtended, but if you want, you can replace that word subtended with the word created. So 1 radian is the angle created by an arc of length equal to the radius of the circle. So what does that mean? It means that if you draw a circle, you take maybe a piece of string, which is your radius, and you tie a little loop in the end of the string, and you put your pencil in there, and you hold the other end of the string in place. So what I'm talking about doing here is taking a piece of string with a little loop on it and another loop on the other end, and you put your finger here and you pull the string tight, and then you take the pencil and you draw a circle by rotating that string around. If you now create that circle and you take that piece of string and wrap it around the edge of the circle, you will have to rotate through an angle of 1 radian. And the abbreviation for radian is rad. From now on, though, if you ever see an angle and it does not have units, if I just tell you, for example, that theta equals 2.38, if you don't see units there, you need to know that it means radians. That's why your math teachers, myself included, have always harped on you that if it's in degrees, you need to put the little degree symbol. So we can write either rad for the symbol for radian, we can write the word radian for the unit, or we can just leave it blank. But that's the definition of a radian. Now it turns out that 180 degrees is exactly pi radians. Now what does that mean? It means that if I were to go to a circle and rotate out 180 degrees, so we're talking about the angle from here to there, it's 180 degrees. It's also the same as saying pi radians. What does that mean? People look at the letter pi, it's a Greek letter, they look at the letter pi and they think sometimes it's a variable. It's not. Pi is a number. It's an irrational number that goes on and on and on forever without any repeating pattern. It's equal to 3.1415926 whatever. So if I say to you how many radians 180 degrees is, your answer is it's 3.1415926, etc. Except since that's an irrational number, we are far better served by just saying it's pi radians. All right. So if you look at this animation, we've drawn a circle here and there's the radius of the circle. I pick that radius up and I wrap it around the edge of the circle. Whatever angle that is 1 radian. If I were to extend that by drawing another arc equal to a radius, that would be 2 rads, then 3 rads. You'll notice, and I'm going to let this thing wrap around again, you'll notice that when it got to 3 rads, it wasn't quite at 180. By the way, if that's pi, that's 2 rads, or 2 pi rads. But look at this thing that I'm talking about at the beginning. I'm going to let it repeat. So the angle from that red line that just went up to the next line that's going to be drawn, those 2 green lines, that angle is 1 radian. The angle from the very beginning to the end is 2 radians, and that's 3 radians, and then if you add a little bit more, you get 3 pi. So how much more do you have to add to 3 to get pi? 0.14. And you're going to get used to this. So now we have a question. We're basing this all on the idea that 180 degrees is pi radians. And we want to write how many radians all of these angles are. Well, clearly 0 degrees is 0 radians. And I hope it's obvious that if 180 degrees is pi radians, 360 would be 2 pi. Now, I don't know if you remember this, but when you go back and you look at what you learned in Math 20 in trigonometry, we made a big deal about these angles. We called them common angles or special angles. And the reason they're common or special, everybody, is because they all divide nicely into 180 degrees. So if I were to look at 90 degrees, for example, 90 degrees is exactly half of what we're looking at here. 90 degrees cuts this pi radians, which is 180 degrees, into 2 equal pieces. So each of those angles that I've shown are 90 degrees. Well, what does that tell us? That tells us that 90 degrees is pi over 2. I want you to really roll that around in your head. 90 degrees fits inside of 180 twice. So 90 degrees must be half of 180, which means it's half of pi because 180 is pi. You really need to start thinking in terms of chunks of pi or chunks of 180 degrees. If I go back now and I look at 60 degrees, 60 degrees goes into 180 exactly 3 times. So if I draw an angle from here to here, that's 60. From this point to this point is 60, and from this point to this point is 60, which means that there are 3 60s in 180, which means if the whole thing is pi, then this must be pi over 3, this must be pi over 3, this must be pi over 3. Because 3 pi over 3s would give you pi. And again, I think visually it's very useful for you. It's very useful for you to see splitting apart that half circle into 3 60-degree chunks. So what does that tell us? That tells us that 60 degrees is pi over 3. And I'm not writing the word rad because we don't need to. 45 degrees. Well, how can you split up 180 degrees into 45-degree chunks? You can do it by breaking it apart into 4 pieces. So I'm going to get rid of this. This is just kind of scrap paper for the purpose of my explanation. So 45 degrees, let's use this color. I know I split it apart into 2 pieces to get 90. Well, if I split 90 degrees in half, I get 45. Which means that there are 4 45-degree chunks. There are 4 45-degree chunks in 180. So 45 degrees is pi divided by 4. And I know that many of you are capable of visualizing this in your brain, but not everybody is. And it's why I think it's important to go back and look at this diagram. If I were to look now at 30 degrees, well, 30 degrees, there's 30, 60, 90, another 30, another 30, and then finally another 30 to take you around to 180. So if you count how many pieces there are here, the the whole thing you're looking at is pi, well, there's 1, 2, 3, 4, 5, 6 pieces, which means 30 degrees is pi over 6. And this is difficult for me because if I were to explain this to you in the classroom, I would be showing you these pieces by rotating my arm around, and I can't do that because you wouldn't see it. The bottom line is 30 degrees is pi over 6. So from here on in, these need to be familiar to you. You need to know these numbers. So I'm going to pause there. Does anybody have any questions so far? All right. Now we're going to review something that you learned in Math 20. And we call this coordinate trigonometry. It's the idea that we put angles on the coordinate grid. And we're no longer limiting ourselves to angles in triangles. We call them rotation angles. A rotation angle is formed by rotating something called an initial arm to a location called a terminal arm. And the rotation angle is the angle that you rotate through. There's a standard here, and the standard is that the initial arm is always on the positive x-axis, and it always rotates around the origin. So the bottom line here, everybody, is when we talk about a rotation angle, we always start here and rotate it to some final position. There's a rule, and you may remember this from last year, and the rule is that a positive angle is counterclockwise. So if that angle that we're looking at here is about 140 degrees, then we would say that it's positive 140 degrees. If you ever rotate in a clockwise direction, then however many degrees or radians you rotate, that's a negative angle. So positive angles are counterclockwise. I know that that may be counterintuitive to you. The first time I heard that, I went, well, why isn't positive clockwise? That makes more sense. The reason, or how you can remember that positive is counterclockwise, is that you will rotate through the 4 quadrants in the order of those quadrants. So you go from quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. That's a positive rotation. Okay, warm up. Now we're going to write the measures of all of the positive rotation angles from 0 to 360. Now, I just want to check here. In your handout, I believe you have do you have a blank page in your handout that looks like this, except you have the bottom part as well?
I don't see one on mine.
Okay, so then in the pack of materials I gave everybody, you will find a handout called Angles on the Unit Circle. If you don't have that available, then what you can do is sketch it on a sheet of paper. It really doesn't matter. You have it?
Is it the one in the back of the... I see it now, sorry.
It's just on the next page, isn't it? It is. Okay, so if you turn the page, you see this blank circle. Is that correct?
Oh, no, it's on a separate.
It's a separate sheet.
Yeah.
Okay, so you need to take a second and find that separate sheet. If you can't find it, then it's not a big deal. Find something nearby that's circular that you can trace, or if you're really good at drawing a circle, just draw a circle as best as you can. You're going to have to learn how to draw this anyway. That's not a bad circle, it's a little flat. And then draw a line across the middle horizontally, a line across the middle vertically, and then look at how I draw the other angles in. I need to go halfway in to draw the 45 degree in each quadrant, halfway as well, and then I'm going to split this into 3 pieces. So there's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So you end up, this is a 30-degree chunk, this is a 45-degree chunk, and this is a 60-degree chunk. But hopefully you have that sheet of paper there. So I'm going to go with the assumption that you have the sheet of paper there, and we're going to label all of the angles. And you need to be able to do this for a reason, for many reasons. First of all, we want it to be in degrees and radians, so I'm going to put down here 0 degrees / 0 for 0 rads. I can put up at the top 90 degrees or pi over 2 rads, and I really don't believe it's a matter of memorizing that 90 degrees is pi over 2. It's a matter of knowing that 180 degrees is pi rads. I hope you understand that I'm not saying 180 degrees divided by pi. In fact, maybe I should put or pi. 0 degrees or 0. So once you know that 180 degrees is pi, half of 180 is pi over 2. Half of pi over 2 would be pi over 4. So 45 degrees is pi over 4. This is a 30-degree chunk here, so this is 30 degrees. Sorry for pointing, it's a habit, and you can't see me pointing. This one is 30 degrees, which is pi over 6. There are 6 of those in 180. And this top one here is 60 degrees, or pi over 3. Now again, if we were in class, I would be showing you with my arm. But here's what I'm going to do instead. I'm counting off right now multiples of pi over 6. So there's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So if you now look at what I'm writing, and this is tough from a distance, but I said that this first bluish dot is 1 pi over 6. We've already labeled it. I said this one is 2 pi over 6. But 2 over 6 is 1 over 3. We've already got pi over 3 written there. This simplifies to pi over 3, so we don't need to write anything there. It's already done. I said that the third green dot is 3 pi over 6. Well, when you simplify 3 over 6, you get 1 over 2, and we've already got pi over 2, so we don't need to write anything there. So again, 1 pi over 6, 2 pi over 6, 3 pi over 6. This one is 4 pi over 6. So just a second. Off on the side, 4 pi over 6 is 2 pi over 3. I reduced the 4 over 6 to 2 over 3. So again, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. This one is 5 pi over 6. And what is interesting is many of you will discover it's easier to find these angles in radians than degrees because they're easier to count. By the way, this would be 120 degrees. This would be 150 degrees. And we're done with the pi over 6s. Let's do the pi over 3s. So I am going to label the pi over 3 chunks using hot pink. This is 1 pi over 3. This is 2 pi over 3, which we already have. And this is 3 pi over 3, which is pi. Now we can do the 45-degree chunks. And again, this is not just an exercise in mathematics. There's a reason why we need to know how to do this. This is 1 pi over 4, 2 pi over 4. This is 3 pi over 4. And you know what? I'm really interested in the radians. I don't care about the degrees, but we could figure out the degrees. This, I think, is 135 degrees. I would ask everybody to look at that 135 and ask yourself how I'm getting it. And hopefully you're saying that we're taking 90 degrees plus 45 degrees. So those are all of the angles in quadrants 1 and 2. I'm going to pause there before we get to quadrants 3 and 4. Any questions with any of those numbers? All right. So we get into the next quadrant. Don't forget that this is pi radians, but also don't forget, and I'm going to just move things down for a second and then move it back. Don't forget as well that we had this other half of the circle. And that 180 degrees was actually 1, 2, 3, 4, 5, 6 pi over 6. So that's 6 pi over 6 to there. So if that's 6 pi over 6, then this is 7 pi over 6, this is 8 pi over 6, this is 9 pi over 6, 10 pi over 6, 11 pi over 6, 12 pi over 6. You are, I hope, going to get to the point where you see 30-degree chunks as pi over 6, which makes this angle 7 pi over 6. This angle is, I'm going to do this on scrap paper, so I'm going to erase it, 8 pi over 6, which is 4 pi over 3. This would be 9 pi over 6, and we can reduce 9 over 6 down by dividing top and bottom by 3 and getting 3 pi over 2. Well, I want to just take a little detour away for a second. 3 pi over 2 is at the bottom. That should make sense to you because this is a pi over 2, this is a pi over 2, that's a pi over 2. It's 3 pi over 2s. Okay, where were we? 9 pi over 6 at the bottom. That would make this one 10 pi over 6, which reduces down to 5 pi over 3. And I want to talk about these two, this one and this one, for a second. We arrived at those by looking at chunks of pi over 6, but we could have arrived at those by looking at chunks, not great, but chunks of 60 degrees. It's a little sketchy on the bottom there, but each of these is pi over 3. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, which is what we got, 5 pi over 3, which is what we got. So we're almost done here. We still need to worry about this one and this one. So now I have to go back and talk about the chunks that are 45 degrees. 45 degrees was this piece, and this piece, and this piece, and this piece. So there are 4 of them to get to 180, which means that this point I'm indicating is 4 pi over 4, which makes this 5 pi over 4, 6 pi over 4, 7 pi over 4. And I guess I missed one here. Going around pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. And of course, we can put in all of these angles. I have confidence in you that you would be able to come up with these angles. This is 210 degrees. It's 180 plus 30. This is 225 degrees. It's 180 plus 45. By the way, you might notice that the angle between these points is always 15. 4 pi over 3 is 240, 180 plus 60. This is clearly 270 degrees. 270 plus 300, 270 plus 45, and 270 plus 60. So I know it's a little intimidating because you're looking at this whole circle with all these numbers all over the place, but you need to be able to identify those locations from those angles or those angles from those locations. Any questions at all with labeling those angles now? All right. So now what we're going to do is just do a quick review here to get our minds wrapped around rotation angles. So convert the following degree measures to radian measures. Now, 75 degrees is not, if you have that sheet of paper in front of you that we just wrote on, 75 degrees is not one of those special angles. So we can't just look at that sheet and know the answer. But what we can do is use a ratio. And the ratio that will always be useful is to write pi radians. I'm going to actually write the word rad over 180 degrees equals x radians over 75 degrees. If pi radians is 180 degrees, then the ratio of pi over 180 is always going to be the same. If you had 360 degrees, which is twice 180, you're going to have 2 pi, which is twice 2 pi. So we're going to cross multiply here, except there's a little wrinkle. When we cross multiply, we get 75 pi over 180. This is equal to the angle in rads, and we want to calculate that. But since pi is irrational, we don't want to bring in a whole bunch of infinite decimals into our answer. We need to take 75 divided by 180, and we need to figure out what that is in lowest terms. Now, I suppose you could just go to your calculator and enter 75 divided by 180 and go math, enter, enter. I believe it's going to be 15 over 36, but since I can't just look at you to verify whether my math is right or not, I guess I should calculate it. 75 over 180 is in fractional form, 5 over 12. Oh, I said 15 over 36, and that reduces to 5 over 12. So the answer is 5 pi over 12 radians. And again, if you wanted to know what that meant as an actual number, what it means is you take 5/12 times pi. This is how many radians it is. It's about 1.31 radians. Now we're asked to sketch this. I think in this particular question, it's easier to sketch it by just drawing something that we think is 75 degrees. Looks about like that. So typically how you indicate that is you say theta equals 5 pi over 12. Could you put 75 degrees here? Sure. So that's the first example. Let's take a look at the second. Negative 120 degrees. Now, will a ratio work? Can we take negative 120 degrees and set up a ratio by going pi rads over 120 degrees, pi rads over 180 degrees, that's your ratio, equals x over 120. Well, yeah, you could, but, and I can't look at your faces to gauge your reactions here, but I hope that many of you see 120 degrees is a multiple of one of those special angles. It's a multiple of 60 degrees. I will show you how to use a ratio in a second, but since 120 degrees is 2 times 60 degrees, I know that 120 degrees is 2 pi over 3, because pi over 3 is 60. So I don't really need to do any calculations here. I could just say there is negative 60, there is negative 120. So this is what the rotation angle looks like. It's negative 2 pi over 3. Over here in my brain, I'm not worried about what the negative is. I know the negative is clockwise. By the way, if you cross multiply here, you get negative 120 pi over 180, and the negative 120 over 180 reduces to negative 2 over 3. Any questions with that example? All right, 2, convert the following radian measures to degree measures. If you want to use a ratio here, you can, but I think it's very awkward. Instead, you simply do the following. It's 3 pi over 4, but pi is 180 degrees. 3/4 of pi means 3/4 of 180. Now, before you calculate that, some of you already have, I know, but, well, let's calculate it. It's at 135 degrees. I'd better just check. Okay, 135 degrees. I will tell everybody right now that for me, it's easier to locate this and quicker to locate that than it is to locate 135, even though they're the same number. They're the same angle. Because when I find 3 pi over 4, I just say, well, look, it's 1 pi over 4, 2 pi over 4, 3 pi over 4. It's right here. And if you locate 135 degrees, now you have to start subtracting 90 and doing some mathematics. But anyway, the rotation angle is this. And we can write it in. Theta equals 3 pi over 4. Let's try another one. Or 135. I don't care which number you actually put down. Negative 11 pi over 6. Well, again, I'm so used to just showing you with my arms, but I guess I have to draw this. Negative 11 pi over 6. Pi over 6 is a 30-degree chunk. I'm going to highlight the 30-degree chunks on this circle. Now, my circles are never perfect, but they're close enough for you to get the gist of what's going on here. Those are all 30-degree chunks, which means they're chunks of pi over 6. Okay. Starting at 0, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6 in a negative direction. And that means that when we draw this, we are actually drawing an angle at 30 degrees, but we're labeling the angle as saying negative 330 degrees. So we've converted it at the same time, really. I'm saying this is negative 11 of those, but that's negative 11 times 30 degrees, which is negative 330 degrees. This whole messy diagram you see on the right that looks like the spokes on a tire is a very helpful one. I just want to see where we're at. Okay, let's do one last one here, 6.5 rads. Well, now we have to use a ratio. This is an angle in radians that does not make reference to pi. So I need to set up a ratio and write pi radians over 180 degrees equals 6.5 radians over x degrees, and I have to cross multiply there. When you set up your ratio, notice, I don't want to spend too much time explaining cross multiplication and ratios, but I do think it's important. Notice that these two are in the same fraction because pi radians is the same as 180. Notice in the other fraction, I have 6.5 radians on the top because radians is on top of the left side. So now I cross multiply. And I get x equals 6.5 times 180 over pi. I do need to figure out what 6.5 multiplied by 180 is. Why am I thinking 690? Excuse me. 6.5 times 180. Yeah, I knew that could be right. 1170 is what we get, and it's over pi. So, this is weird. You actually have an angle in degrees, don't forget this was x degrees, that has reference to pi in it. And you could certainly calculate what this is approximately equal to by taking 1170 dividing by pi. It's about 372 degrees. And that's going to be helpful for us in sketching this. So we can say it's about 372 degrees. So 372 degrees is around to 360 and continuing on a few, well, 12 degrees more. So that is the rotation angle. So we're about to move on to something different now. Does anybody have any questions regarding drawing these or converting? They can be specific to the examples we did, or you might have a general question. Because this is a new language for you, this whole radian thing, it might require you to, as homework, study this stuff and go through it later on. Okay, now we've got a definition. This is called coterminal angles. What a coterminal angle is, or a set of coterminal angles, are angles that have a different measure but the same final location. So if you take a look at 50 degrees, I start off at 0 degrees and I rotate counterclockwise 50, I end up there. If instead I rotate 410 degrees, that would be 360, plus another 50 would be 410, I end up in the same location. It's pretty easy to see why that's what the definition means, because the word is co-terminal. They have the same terminal angle. So, sketch a rotation angle of 60 degrees. That should be like stealing candy from a tired baby. There it is. We can label in 60 degrees if we like. Probably should. And then we are asked to come up with other examples of angles that are coterminal with 60. Well, if you look at your screen right now, if I wanted to take this arm from its current location and rotate it further and end up in the same location, I could rotate another 360. Or I could take that 60-degree angle and I could rotate negative 360. And I think it's obvious to most people that to get a coterminal angle, you're going to either add or subtract multiples of 360. So, for example, 360 degrees plus 60 gives me 420 degrees. That's a coterminal angle. 420 degrees plus 360 gives me 780 degrees, I think. Yeah. I could keep going. 780 plus 360, I believe, is 1140 degrees. I'll just double check. Carrier 4, yep. Or I could take 60 degrees minus 360, negative 300. I could take negative 300 and subtract another 360 and get negative 660. I hope that you get the idea. Again, I would normally look at your faces and look for some nods here, but remember that you have to interrupt me if you have a question or you're not sure. I know that puts a lot of pressure on you, but does anybody have any questions with that first example 3? Because I'm going to pick up the pace here a little bit, I think. What's a rotation angle of negative 275? Well, negative 270 takes us to here, so negative 275 is a little sliver past. So this is negative 275 degrees. I'm not going to write down these answers. I'm just going to calculate them on my calculator, and you can choose to write some down. If I take negative 275 and I add 360, 85 degrees is coterminal. So is 445 degrees. So is 805 degrees. If I wanted some other negative coterminal angles, I would go back to the original angle and subtract 360. So negative 635 is one, and you could continue in that fashion. Any questions with 4? All right. So now what about 5 pi over 6? Well, 5 pi over 6, you should know, and again, you're watching the screen, you should know that pi over 6's occur here. Get my pen going first. You should know that pi over 6's occur starting at 0, 1, 2, 3, 4, 5, 6. So 5 pi over 6 is here. And now this is going to be challenging for me to explain this because you can't see my arms. This is 5 pi over 6. I'm going to continue to put marks of pi over 6 here. So that's 5 pi over 6. You're watching the screen. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pi over 6 is coterminal. 17 pi over 6, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 pi over 6 is coterminal. I could go back to the 5 pi over 6, which is here, and start subtracting. 5, 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7 pi over 6. There's other ways to get them, but I think that's the most straightforward way. Questions with 5? Okay, now I'm going to show you a different way to get coterminal angles now in this particular example. Because sooner or later we have to take that leap away from the concrete where we draw something into the realm of abstract where we just work it out. The bottom line is that we need to take 5 pi over 6 and add or subtract multiples of a full revolution. And a full revolution is 2 pi. But 2 pi is 12 pi over 6. And that should say multiples, and I'll leave it up to you to come up with how you know it's 12 pi over 6. I know it's 12 pi over 6 because 2 is 12 over 6. You could count off 12 pi over 6s to get a full revolution. But look at all I have to do. I have to take 5 pi over 6 and I have to add 12 pi over 6. Well, if I had 5 puppies and I added 12 puppies, I would get 17 puppies. I don't have to worry about a common denominator here because I've already created it by talking about 12 pi over 6. So there are other things you could do to determine the coterminal angles. Let's try one more. Negative 3 pi over 4. Well, starting at 0, this is negative 1 pi over 4. This is negative 2. This is negative 3 pi over 4. Now I'm going to count off coterminal angles because to me it's just a little easier to explain. That's negative 3 pi over 4. 0, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8 pi over 4. So negative 8 pi over 4, I'm just going to double check that. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi over 4. I don't know why I lost my count there, so let me start again. This is 0, negative 1, negative 2, negative 2, that's why I did it. I forgot these. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, 9, 10, negative 11 pi over 4. I could go in a clockwise direction. 1, 2, 3, 4, 5, 6 pi over 4. I could continue. 7, 8, 9, 10, 11, 12, 13, 14 pi over 4. Any questions with that example? Okay, I think we have one more thing to cover in this lesson, and it's talking about an expression for all coterminal angles. I hope you would agree, I'm going to go back to one that's easier because it's degrees, that if we continue with example 3b to add multiples of 360, there is literally no end to how many coterminal angles we could get. And for that reason, there's an infinite number of coterminal angles. So what we say is a general expression for all of the coterminal angles would simply be to say 130 degrees in this example here, plus or minus 360 degrees times n. Now n can't just be any number. N has to be a natural number. It can be 1 or 2 or 3 or 4 or 5. And we signify that by using the symbol for the natural number set, which is capital N. If we want an expression for all of the coterminal angles to 7 pi over 3, by the way, notice that 7/3 pi and 7 pi over 3 are the same thing. I can just go plus or minus 2 pi times n, where n, I'm going to use a different notation here because you will see it, is an element of the natural number. So you can say n equals a natural number, or n is an element of the natural numbers. That's it for the first lesson. You can see that there's some homework there. The next lesson is very short, and we want to be done here by 3, and by my clock that's about 1 hour and 7 minutes. I'm going to say we'll take until 2:15, and then we'll do the short lesson. But just before you get started, and we don't have to have a big conversation about this, you can just type something in chat. What I want to know is too fast, too slow, or like Goldilocks, just right. And I want to know your opinion of the pace that I went through the content. If you felt I was going too fast, be honest and let me know too fast. Because if I don't know, if you think it's going too fast, I don't know to slow it down. And please don't be influenced by what anybody else says. I want you to be honest. There's nobody here but us, so I want honesty here. And those messages are starting to come through, and I appreciate the feedback. So these questions from your textbook deal with rotation angles and coterminal angles and converting between degrees and radians. And this is going to be, for some of you, you'll think you have it, and then you'll get to a question and, oh man, you just forget what to do. That's what I'm here for. So while you guys are working in the next 20 minutes or so, I'm here to help you. If you have a question, you can unmute your mic and let me know. Thank you for that, Aiden. You can unmute your mic and let me know, or you can type something in the message. I'm likely to hear you before I notice the message. Seems to me that the pace was about right. I could have picked it up a little bit in places, but at least nobody said too fast. That's good. So get started on that. I'll shut up and let you guys get to work.